So this video is intended to help students with the concepts of parallel and perpendicular lines and how to write equations for those. So what you have to know about parallel lines is parallel lines are lines that have the same slope. Now, they'll have a different y-intercept, but they'll have the same slope and they'll never intersect. See, lines can either intersect at one point, or they can intersect at all points and be the same line, or they can not intersect at all and be parallel. And when they're parallel, they have the same slope but a different y-intercept. So they'll have the same slantiness or steepness, but they'll cross the y-axis at a different point. Okay, so for example, you might have two lines that look like this that have the same slope. In y equals 3x minus 1 and y equals 3x plus 2, they have the same slope of 3, but they have a different y-intercept. So you can recognize if lines are parallel or not by their slope. Now, perpendicular lines behave in a different way, and their slopes are opposite reciprocals. Another way to say that is their slopes multiply to make a product of -1. So an example of lines that have perpendicular slopes would be y equals 1/2 x plus 2 and y equals -2 x minus 3, for example. See, the slopes are opposite reciprocals. They're opposite signs. One's positive and one's negative, and they're reciprocals or turned upside down of each other. So when we look at that, the slope of the first line is 1/2, and if I multiply it by the slope of the second line, which is -2, and I'll write that as -2 over 1, when I multiply those, I get -2 over 2, which is -1. So you can identify lines that are perpendicular by their slopes if they're opposite reciprocals. Or another way to look at it is if you multiply the slopes, the product is -1. So now I thought I'd do a couple of examples out of our algebra textbook. This is from lesson 5-6 on parallel and perpendicular lines. The first question is question number 9. And this question will ask us to find the equation of a line that's parallel to another line. But they don't give us all the information. So what we have is we have the equation of the first line, and we need to find an equation of a line parallel to that line, but there's an infinite number of those. But we want the one that goes through this point, 1, -3. So when I look at this one, this is in point slope form, and it's not my favorite form of a line. My favorite form is slope intercept. So I'm going to change that into slope intercept to make it a little easier to work with. And that's just a preference, but it's going to work out nicely in this case. So what I'm going to do is I'm going to get this into y equals mx plus b form. And to do that, first I'm going to distribute the 4 and make this 4x minus 4. And this side will still be y plus 2. So to get y by itself over here, I'm going to need to go add a -2 to both sides. So what I've just done is I've changed the form of the line from point slope into slope intercept form. So this is the same equation I started with, and now I'm looking for a new equation of a line that's parallel to this line but goes to this point. So I go back to slope intercept form, which is y equals mx plus b. And what I want to do is I want to substitute into that the values that I know and solve for the ones that I don't know. So if I know that I'm looking for a line parallel to this line, I look at this slope at 4, and I want my slope of the new line to be 4. Then I'm going to need some x and y values. And of course, for any line, for any equation of a line, you have an infinite number of x and y values to choose from. But I don't want any of those x and y's because I want it to be the line I'm looking for, which goes through this point. So this is my x value and this is my y value. So in my equation, where it says x, I'm going to substitute 1. and I'm going to put plus b, and then where it says y, I'm going to put in a negative 3. So if I simplify this, I get 4 right here, 4 plus b equals negative 3, and I'm left with one variable, which is what I want, because I need two things to make a line, or the equation of a line. I need the slope and the y-intercept. So since I have the slope, what I really need to find is the y-intercept. So if I solve for b, I will get the y-intercept, and b is negative 7. So in this equation, it would be y equals 4x, because my slope is 4, it has to be parallel to that, but it crosses the y-axis at negative 7. My y-intercept is negative 7. So the second question I'll do is question number 21. And this question asks us to find a line that is perpendicular to another line. So what it says is find a line that is perpendicular to y equals 5x plus 4 and goes to the point 1, negative 2. So going back to my favorite version of the line, the favorite form of the line, y equals mx plus b, or slope-intercept form, I know that I can find the m, or the slope, from this equation. If I'm looking for the slope, I know since it's perpendicular that it has to be negative 1/5, because it's the opposite reciprocal of the other equation's slope. And since that slope is 5, my slope of my new line has to be negative 1/5. If you multiply 5 times negative 1/5, you have a product of negative 1. So I can put that right in here for m, negative 1/5. Now what I need is an x and a y, and I happen to have an xy point right here that's on my new line. So the x value is 1, and the y value is negative 2. And the only thing left in my equation is b, or the y-intercept. So once again, I can solve for b. Doing the math here, we get negative 1/5 plus b equals negative 2. So I've almost got b by itself. If I add 1/5 to both sides, then b would equal negative 1 4/5. Or another way to write that would be b equals negative 9/5. Either way is okay. So now that I have my slope and my y-intercept, that's all I need to write an equation of a line. So my answer would be y equals negative 1/5 x minus 9/5, or another way to write that, y equals negative 1/5 x minus 1 4/5. So there you have it, parallel and perpendicular lines.